Fractals are images that are made up of smaller images that look similar to the large image. Those smaller images are made up of similar smaller images, and so on until infinity. They can be used to make amazing patterns. To understand how fractals are made, I'll explain the complex numbers, the complex number plane, and mathematical functions. Complex numbers can be understood by looking at the number line. Real numbers are numbers that lie on the number line. If you add another number line that goes through 0, you can call this the imaginary axis, and together they make the complex plane. You have the real axis and the imaginary axis. For example, this point has a real number 3 and an imaginary number 4. In math, we write this as 3 plus 4i, and this is known as a complex number, where I stands for imaginary component. Every point on this complex plane is a complex number, which has a real component and an imaginary component. Every complex number has a special relationship to 0 on the complex plane. If a line is drawn from any complex number to 0, an angle can be measured from the real axis. There are certain rules with complex numbers, and one of them is that when you multiply two complex numbers, you add the angles and multiply the length. I'm now going to explain what a function is, and eventually you will see why it is important for fractals. On the complex plane, there are infinite complex numbers. A function is a mathematical rule, and it is used to take one point of the complex plane and move it to another point on the complex plane. The letter F is used to stand for function. The letter Z is used to stand for a point or complex number in the complex plane. The term f or z simply means a function of a complex number and is written like this. To make a rule, you say f of z equals something. For example, if you want to move a complex number 3 units to the right, 3 is added to the complex number. A function is written and is shown as f of z equals z plus 3. Fractals look at what happens to complex numbers when they are repeatedly mapped using the same function over and over into infinity. A function will take a result and map the result to a new position, and then take that result and map that result to a new position, and so on into infinity. In the example where the function added 3 to every point, each result always moves the new point 3 units to the right until infinity. In maths, this point is always said to escape to infinity. Functions can be written in many different ways. Not all points escape to infinity in a straight line. They might curve outwards or spiral outwards. Functions can also be written where points move inwards towards the origin 0. Functions can also be written so points move in a circle or come to a stop. Functions are said that they either escape to infinity or do not escape to infinity. They are said to be bounded. What happens to a function where the complex number is multiplied by itself? We write this as f of z equals z squared. If you multiply a number that is smaller than 1 by itself, you get an even smaller number. If you multiply a number greater than 1 by itself, you get a greater number. If you apply this function to a complex number with a length greater than 1, then the result will be a length even greater. Remember, length is multiplied and the angle is doubled. The position of the new point is rotated outwards to the left and even further from 0. If you apply this function to a complex number with a length less than 1, then the result will be a point rotated inwards towards 0. Points spiral inwards and get closer to 0. If you apply this function to a complex number that has a length equal to 1, then points are rotated in a circle around 0, with the radius equal to 1. The length never changes because multiplying 1 times 1 equals 1. Points stay bounded. For the function f of z equals z squared, points on the complex plane that stay bounded can be coloured black, and for the points that escape to infinity can be coloured blue. This is known as a fractal. Computers are used to follow the path of all complex numbers on the complex plane. When they are mapped under a particular function, computers are needed because there are infinite points and therefore infinite calculations to be made. Also, computers can assign colors for different results, so that the great patterns can be made. For the function f of z equals z squared, we got a circle image, but for different functions, we get a different image. For example, if you have the function f of z equals z squared plus 0.25, you get the image. This is a zoom in of the last fractal. Blue points are points that have escaped to infinity, and black points are those points that have stayed bounded. At the border, the computer can be told to color points that have escaped to infinity quickly with blue, and those escaped slowly another color like red or yellow. There are infinite types of fractals because there are infinite complex numbers. Fractals that make great patterns all use the basic function f of z equals z squared plus a complex number. The most famous one would have to be known as the Mandelbrot, that looks like this. There are many computer programs that you can download to create your own fractal patterns. I've used one called Fractal Extreme.